Hello everyone, I'm Mustafa. I'm from group number 4. We're doing today a weekly development progress status report for Geo 2029 Civic Engagement Initiative Phase 2. So meet our team, Hamza, Hershey, me, and Dimi. So we will start with our project overview. So as a team, we are rebuilding a full data pipeline and dashboard that shows voter participation trend across Toronto. We're using updated dataset and tools like Python and Tableau to make insight more accurate and easier to understand. For our data gathering overview, for provincial election part, we collected all our data from electronic Ontario Open Data Portal. The file include electors, voter cast, valid ballots, and turnout information. We logged everything in our shared data inventory sheet, the source format year and variables, so the provincial dataset stay consistent with the federal and municipal dataset. For our documentation work, we updated inventory with data set details, column description, and any issue found. We also recorded the cleaning steps so everything stay clear and consistent for the whole group. For all tools and architecture, we use Python mainly, pandas inside Visual Code, and Jupyter Notebook, Tableau. We'll be able later to visualize the SharePoint and Google Sheet help us keep everything organized. This setup keep the whole group aligned. For our data cleaning, here we are summarizing a cleaning step we applied to a provincial data set. We loaded the raw data, CSV standardization, the column name, removed, duplicated, and filtered out the total rows. We converted all voter related fields into numeric values, handled missing values, and recalculated the turnaround percentage after finishing cleaning. So we have here some screenshot, and here we have a live code is running. And we're going to run it again. So we have this one, the raw data. You can see there is a lot of data and missing data. And after we run it, this is the preview of the raw data. This is the preview of the clean data. And here is the percentage recalculated and rehandled. And this is after it finished, store it as clean data. So my colleagues will continue now. Thank you so much for that.
Hello, Professor and dear team. I'm going to present from federal elections point of view. So to talk about the federal election, I have created this Jupyter notebook in which I tried to analyze the data shapefiles from the federal electoral district boundaries point of view, and also looked at the Ontario 2025 results and having a provincial shapefile for the electoral district as well. And then I use the CSV file for the 42nd general election poll by poll election results for this part of analysis. So the data sources, as I explained, are two shapefiles and one CSV data file that I use from Canada Open Data Sources. The tools that I try to use on Jupyter Notebook for my analysis is the Python language itself and the libraries of Python, including pandas, GeoPandas, and Matplotlib library. Matplotlib library I have used in the capacity of data visualization. On pandas, it is used for data manipulation, which is also known as data wrangling point of view. GeoPandas has been used for integrating the shapefiles to get better visuals for the data as well. To talk about the architecture regarding the federal election. So I followed these different 6 steps, starting with the data gathering part, which was so available online. And we have a Google sheet with all the data sources that we will present with our project as well. Then I did a bit of cleaning and standardizing the data with the variable names and the features and the variables in the data itself. Then aggregating to writing level, did a bit of geospatial joins by integrating the shapefiles. I used to do it in Tableau, but Tableau was a bit limited for this kind of analysis. So I had to go with GeoPandas on Python library to do this. Then I did the mapping and the visualization, as I mentioned. And the last part is I added a bit of machine learning, which is the clustering. Instead of doing any predictive analysis, because it's talking about election results, so which is influenced a lot by a lot of different policies by different political parties and government itself. So I try to go with clustering instead of doing predictive modeling or predictive machine learning. Okay, so in data cleaning workflow, so I tried to standardize the ID fields because the data was available online. It was very unstructured, unsymmetric, so I had to do a lot of work on the cleaning part to make it standardize columns and features itself, and then converted the vote and electoral counts to make it more numerical data. Removed any invalid rows that I had and empty polls that a lot of electoral votes bank had them. So I had to do a bit of cleaning there and do some data wrangling as well. to talk about the geospatial mapping here. So for geospatial mapping on federal elections, so I joined writing level, result of federal boundaries as based on the shapefile, produce maps based on winning parties, clusters, and turnout ratios, and then compare the federal and provincial or Ontario boundaries as well. I'll show you the results from the Jupyter Notebook itself. So if you can see that I tried to include all the libraries that I used. First, I did pip install them on Jupyter Notebook before using them. I did sklearn library for the machine learning algorithm and specifically the clustering and the k-means clustering in the clustering algorithms. I did just a bit of a matplotlib uh, uh, changes the properties how the graphs will look like, and then give them the links to the data sources in my folder itself. After that, I loaded the data, saw the initial head rows of the shapefiles, what kind of column names do I have, and then I check them based on the dot columns and dot d types, the data types for me. Then I try to do renaming a few of them to make it look very symmetric with and aligned with the data source as well, which is the federal ID and the federal name specifically. Then I started with the Ontario 2025 provincial electoral district shapefile. So I did a lot of cleaning involved and then back and forth. And it took a lot of time actually to make it clean and look something more easy to read for the user, and so that the graphs and the charts that I will do, the visuals, that is more appealing and easy to read and self-explanatory as well. So I did a bit of cleaning and then coming to the visualization parts. These are like the winning party by federal electoral district. So you can see the different parties and based on their vote banks, how where they have won in this election. Then I further worked on the Toronto-based electoral district. So you can see that Liberals were dominating in this region. And then I tried to plot it with the provincial, federal, and boundaries based on the shapefile that is available online as well. I further did a bit of Calgary as well to include like different parties, and then you can see Conservative were very well did very well in the Calgary region, but Liberals had a seat as well there. Now, the idea of machine learning was to clustering the vote patterns based on different regions, and these are the different clusters that it received, and these are very much aligned to the actual data. So the model did perform very well turnout, which is again very relevant to the data itself. So it was very appealing to see the results of this unsupervised clustering algorithm on this data. So to summarize everything, I would just edit here that I have loaded the federal electoral district boundaries and poll by poll elections, then clean and standardizing it, then joining the shape files and the data file, source file together to create some nice visualization for you. And to talk about further extension of this project to talk with our client is that to integrate more of the social demographic covariates from the census, like income-based, gender-based, education-based, ethnicity-based voter pattern and turnout, and then do a bit of more predictive modeling to see if we can support any party in the future elections, and then create like a nice more web application based on dashboard or Tableau dashboard or Python Dash. That's from my end, and now I'll continue with my group members. Thank you so much.
Thank you. This is the Municipal Toronto open data for 1,500 polling substation using Python and Pandas. And for the step one, I loaded and inspected the raw data, and we downloaded the 2022 voter statistics and the 2018 from the City of Toronto to open data. The raw file contains mixed rows, polling station and ward totals and grand total, column names, add spaces, asterisks, and inconsistent formatting. Here we have the screenshots of showing the systematic data cleaning, stripping and standardizing all column names, separating real polling substations from total rows, extracting clean word numbers using regress, converting every count to numeric, finding missing values and missing values with zero and dropping fully empty rows. Results perfectly clean data set for 2018 and 2022. Here on this slide, the descriptive data statistics, where average turnout per polling station 25.9%, more than 300 subdivisions below 15% turnout. Some locations, senior residents exceeded 90%, and we confirmed the official citywide turnout to be of 30.0%. And on this slide, the group we have the ward level aggregation. Group the 1,535 subdivisions by 25 wards, calculated total electors, total votes, and average turnout per polling station. Highest average ward was 31.9%, lowest average ward was ward 23, which is 17.4%. Clear geographic pattern, internal suburban wards performed worse. And on this slide, we have the key visualization produced here, is histogram of all 1,535 polling station, heavily right-skilled long tail, school board eligibility pie chart, public secular 81.1%, Catholic was 17.7%, and we have the scatter plot, positive relationship between same-day additions rate and turnout. And also for the 2018 versus 2022 comparison, turnout fell from 14% to 30%, making it 11 points drop. And we have the hands off slide here. And also the summary of the findings here is that Toronto Municipal for 2022 municipal election had historical turnout, 30% is 30% is sharp 11% point decline from 2018, and large geographic disparities within suburban wards showing the lowest participation. This concludes the data cleaning and analysis section over the period. Thank you.
Morning, Professor. I'll walk you through the integration part of our project, which includes taking raw CSV files and zip files and making it streamlit ready dataset. And the biggest problem we faced was the zip files across years had different column names. And so we implemented dynamic join key detection instead of hard coding column names and came up with a single GPKZ integration. This can be shown in our code. Here are some of the screenshots from our code. As you can see, the utils.py file has helper functions like normalize functions where we lowercase all the column names and get rid of the white spaces and null values, and we find the column name by keywords and then detect join keys. The join keys can be writing ID or writing name or even name, as you can see here in the possible list. And then we string some of the stringify helpers, and finally the load GPKG function, which will expect canonical columns like year, writing name, but as the problem was the files had different column names. So as you can see, we have used multiple candidates, writing name, UID, FED ID, FED NUM. By the way, these were used in separate files. And same for the writing name, same for year. As you can see, we finally have created the GeoKey, which includes year to identify the election year and the writing number to identify the writing of the certain location. As you can see, the load federal CSV file will load CSV with fuzzy heading mapping, and again it uses multiple column names. Also, one problem we had was the files had French names or even short forms, so we had to take care of those things too. Some cleaning work, and then ensuring the data types are consistent. And finally, data preparation is done by this function, prepare map df, where we create a mapped geodata frame, mapping between the CSV files and the shape files, the unified shape file. And as you can see, it does merging, and also has implemented a fallback logic where if the ID is the writing number is not present, we can use either writing ID or writing name. And it does some normalization, some data cleaning like dropping rows, detecting duplicates, and finally we'll return the merged geodata frame. So getting back to our slide, we can see this is the code which we use to combine the CSV files across different elections. And on the right, we can see this is a screenshot of the code we used to come up with one GBKG file using all the shape files. And this is the prototype website. As you can see here, we can select multiple years, and we can select the type of map for each election type. And we can select if we hover over the writings, we can see the writing name and the voter participation for that election. Again, the issues identified were inconsistent shape files across election years, and this was a big problem. We did not find any shape files for provincial elections pre-2018, which created a bit of inconsistency, and join key inconsistencies, and these are some of the techniques we used. For example, to overcome the join key inconsistency problem, we implemented flexible join key finder, like as we saw in the code. We used multiple columns instead of just one column with like ID, because different data sets has different types of join keys. As you can, similarly, we combined the multiple save files into single GPKG file. And some of the work that we have to complete before the final presentation includes finishing up the Streamlight web app, giving it a final touch, better UI, and then building a visual dashboard which will showcase some of the trends we found in the data. This is the theoretical budget estimate. And in conclusion, I would like to say that we have laid the foundation for a well interactive civic engagement analytics platform that brings previous data from 20 years for the City of Toronto elections in all the three forms of elections. With that, I would like to thank you for listening to us.